Yeah, I'm from New England. Which is in New England. Boston, capital of Massachusetts, Massachusetts in New England.
I did not know that.
I know. Texans can only think about one state.
So I'm going to go to New England.
Alright, 6 minutes. On your own. We're on page 27. Feel free to use your notes from Implicit Differentiation, because that's what all this is about. Folks that are watching at home should be doing the same thing. You're on page 27. We'll share the answers in a little bit. You might want to pause the video or just fast forward, because not much is going to happen in the next 6 minutes. Chris, I see you. Give me a minute.
Thank you.
Clearly have notes. Before you.
Well, if you find 5 reasons why people should be able to the pizza raffle, get those instead of these ones. There's a pizza raffle one. I had my
I'm not so sure. That's not a reason to give you a. They're over there. Nice. Okay, but you have the orange card? You have the orange card? And we've got notes. And your surrounding notes. We've got notes. Everybody's still working. Okay. Alright, I forgot to set my timer, so maybe it was more than 6 minutes, maybe it was less, my apologies. Okay, if number 1 went well, I'm not going to make anybody feel bad if you got this wrong. This should be a straightforward, we can all get this question right kind of question. A. How many guys got A? Not as many as I would have hoped. Okay, so real quick, if you're going to do this, if x squared plus xy equals 10, when x equals 2, find dy dx. I'm going to take a derivative. Derivative of x squared is 2x. The derivative here, product rule. So it's the derivative of the first, leave the second alone, plus the first times the derivative of the second is equal to 0. That's the derivative. Now you can solve for the dy dx if you want to, and that's not too bad. That should be easy to do. Or you could just say, well, I know that x is equal to 2, and plug that in here, and plug that in over here, but you still need to figure out what the y value is. Fleur, how are we going to get the y value? What's your thought? There you go. You know that x squared plus xy equals 10, so 2 squared plus 2 times y is equal to 10. If 4 plus 2y is equal to 10, we should get y is equal to 3. And then you're going to plug that in. You're going to get 4 plus 3 plus 2 dy dx equals 0. Add these together, subtract, divide by 2. So that's why it should be negative 7 over 2. Was E the popular wrong answer?
Sure.
I put B, but that's because I forgot to like put the 10 to a 0, so I added the 10.
Ah, okay. So was D a popular wrong answer?
Maybe that's just me.
Okay. How many? All right, hold on. How many else had the right answer, which is A? 1, 2, 3, 4. Not as many as I thought. Like really, this is the kind of question that everybody should be able to get right. How many else had B?
The y equals 3 right there.
C, D, E. Okay, that didn't add up anywhere near to 28. Okay, I'm a little worried there. Okay, number 2, sine of xy equals x, then what's dy dx? You're going to have to take the derivative. And if sine of xy is equal to x, when you take the derivative, it's cosine of xy, but then times the derivative of the xy, because this is a chain rule problem. Jeanette?
Why couldn't we do like 1 over, oh never mind, that's antiderivative.
Right, you're taking the derivative on both sides. The derivative of sine of stuff is cosine of stuff times derivative of stuff. To do the derivative here, so you're going to have cosine of xy, and then it's 1 times y plus x times dy dx equals 1. Your goal is to solve for dy dx. I could do that by dividing both sides by cosine of xy. So y plus x times dy dx is equal to 1 over cosine of xy. I'd subtract y to the other side, divide by x. That's your dy dx. Yeah. How would I find the second derivative? Well, in this one I wouldn't bother finding the second derivative because we don't need to. There is one coming up that you need to. Additionally, now the issue is going to be you've got a fraction inside of a fraction, so this might be messing you up a little bit. All of your answers are simple fractions. So one thing you can consider doing is multiply by cos xy over cos xy. Is this legal?
Yeah.
Is this really legal?
Yeah.
Right? Why am I going to multiply by cosine of xy over cosine of xy, Henry? Why would you want to do that?
Because it's a fancy one.
This is fancy one, that's why it's okay to do it, but why would I multiply by cos xy over cos xy, Jack?
Because of the keep it flipping right thing, it's like if you cos xy, if you keep 1 over cos xy,
Yep.
and then you flip you flip it with, when it's multiplied with the cos xy, you can have 1.
Okay, I don't agree with that. That's not why you'd want to do this. Jeanette, why would you want to do this?
To get the fraction as a numerator?
Yeah, you've got this fraction in the numerator, and remember, like, we're fraction killers? One of the way that you can kill off the denominator, you can multiply both sides of an equation by anything you want to. But in a fraction like this, you could also multiply the top and the bottom, and that would work as well. Okay. If you made it to the next one, this one's actually not it's not implicit differentiation, it's related rates. And the right answer should be C. The answer for number 2, my bad. The answer for number 2, where'd you go? D. How many guys had D? Okay, I am worried about all the folks who have not indicated a correct answer yet. All right, so here's what we're gonna do. You've got the next 15 minutes. We are in deep work time here. You have a choice to make. You are either going to spend your time working on a free response question. This is on page 30. Or you're going to spend your time getting some practice with derivatives, implicit differentiation, on page 29. This is 15 minutes of work time. Spend it whatever way makes the most sense to you. That's totally okay. I want to spend my time on the free response. So I'm going to I'm going to walk around and check in with you guys, but I'm also going to do some work with the free response so you can watch this video later and get more free response support. Everybody good?
Yeah.
Where are the folks that are doing the free response? Okay, and everybody else is doing multiple choice? Okay, I'm also going to pass back the progress monitor tests, a data sheet that I have for you. At 9:22, we're going to stop practice time and look at the progress monitor and look at results.
Yep.
I was there in a second.
Oh yeah, you said
And for the folks working on the free response, you need to make a change. Part B should be -2, 1, not 2, -1. Pass some stuff back.
So why would be going
Well, Jackie. Where'd my Sheila go? Hi, Sheila. Michelle. I lost my Michelle. No idea what that is. Maryland. Karina. Alyssa. Daisy. Sylvia.
So then negative 1.
Because they're together. They multiply together.
It's going to be negative 1.
But I think you're
Henry.
Yeah.
no te puedo ayudar. Muy solo
Jackie B. Rebecca. Jeanette. Mario. Diego. Gonzalo. Okay, I got you. Jackie B. Sheila. All right. Yeah. Paul. Bell. Okay, Gerson.
Yes,
Michelle. Henry. Henry. Let me just finish passing down. Jesus. Jesus, are you working on multiple choice or free response? Free response. Okay, we're gonna get him. Axel. Sylvia. Adrian. Jose. Rubio. Marilyn. Daisy.
What?
Oh, so then we just add y to the plus y plus y, so 3y equals.
Yeah, you got the for one side.
Right, you get, so then the y would be negative 1, comma 1.
So if I only give you one check mark, it's the day that you need the calculator. You don't have
Oh, you do those numbers.
All right, free response here. If I take the derivative 2x plus 2 plus 4y cubed dy dx plus 4 times dy dx equal to 0, if everybody's okay. I think they awarded 1 point for that. You have to solve for dy dx. dy dx shows up in 2 places. Move the terms that don't have the dy dx to one side. Factor out the dy dx from the others. Yep. And then divide. So negative 2x minus 2. 4y cubed plus 4. If you factor out the negative 2, you're going to get x plus 1. Factor out the 4, you get y cubed plus 1. You can reduce. So you get negative 1 over 2. And I would hope for all the friends that just did the free response, did everybody get part A?
Yes.
Part A, all the friends that just did free response were good?
Yeah. So it's out of 2 points?
I think that one's only out of 2 points.
Yeah.
B, write an equation for the line tangent to the curve at the point negative 2 comma 1. Well, anytime we're going to write the equation of a tangent line, you need the point, and you need the slope, They were kind and they gave you the point. Where do you get the slope from?
The derivative.
From the derivative. They gave you a derivative. All you're going to do is plug in the point, and so you're going to get -1 times -2 plus 1 over 2 times 1 cubed plus 1. -2 plus 1 is -1. -1 times -1 is 1. 1 cubed is 1 plus 1 is 2 times 2 is 4. I think my slope is 1/4. Equation of the tangent line should be L of x is 1/4 x minus a -2, or x plus 2 plus 1. And for the folks doing the free response, is everybody okay? Okay, 1 point for the slope, 1 point for the equation of the tangent line. I'll do another lap and I'll talk about part C in a bit.
Am I doing this right?
Okay, dy dx equals the derivative of that plus 2x. Yep, that's good. It's great.
So I just plug in the y, and then
Right. Right, we want to know what dy dx is. So they've told you that x is equal to -1.
Oh yeah, you get it.
That's great. You know x equals -1, but you still
Okay,
need
that's what I did. That's where I got it.
Okay, so you plugged it in and you get y equals 1. Okay, I believe you. And so you're going to let x equal -1, you're going to let y equal 1, and solve for dy dx.
Do you understand number 1? Do you understand number 1?
I get it. I get it. I did something.
dy dx equals 0, then the numerator, so negative x equals 0, and then
You find the derivative.
the bottom one is not equal to 0. So to determine where the tangent line is going to
Y times
you start by numerator is equal to 0 for the when x is
Saying that all this is equal to 0, it's not equal to 0. It's equal to
because he never did
If you have a horizontal tangent line, that means the derivative.
what unit is that?
Which means the numerator is equal to y.
So,
Unit 5?
so this is your integral.
Yes.
2 plus
I just gave him
2
no, wait, that's the 40.
Oh, isn't it horizontal? The vertical horizontal is like top and bottom.
Oh yeah, you do want
This
to.
is about the horizontal. What's supposed to be
Yeah. So let's take a look at that. Okay, for folks working on the free response, I want to talk about part C. If you're working a multiple choice, just keep going. Is it possible for the curve to have a horizontal tangent at points where it intersects the x-axis?
This is the derivative.
So horizontal tangent line, I know something right away.
The numerator equals 0.
That means that your derivative has to equal 0. Horizontal tangent line, derivatives equal to 0. If you wrote that down, 1 point. For real. Now, hold on. Now you've got to take your derivative expression and set that equal to 0, and now you have to solve it. You've got a fraction equal to 0 what has to happen for the fraction to be 0? If a fraction is equal to 0, the top has to be equal to 0. That's the only way you're ever going to get a fraction that's going to be equal to 0. So the negative of x plus 1 is equal to 0, which means that x plus 1 is equal to 0, which means that x equals negative 1. I'm pretty sure that the College Board gave 1 point for either of these two pieces, and 1 point for coming up with x equals negative 1. Yeah.
So if you, let's say like, you can plug in 0 and 1, so that would be on the top.
If the denominator was equal to 0, then you'd have a vertical tangent line, not a horizontal tangent line, and that would be a problem. Okay? So here's the thing for any of the folks working on the free response. The question says, is it possible for the curve to have a horizontal tangent line where it intersects the x-axis? We haven't actually answered this question yet. All we've done is figured out that if x equals negative 1, you're going to have a horizontal tangent line. Paul, what are your thoughts? If you put negative 1, x equals negative 1 back into the original equation, now you've got negative 1 squared plus 2 times negative 1 plus y to the 4th plus 4y is equal to 5. Negative 1 squared is 1 minus 2, y to the 4th plus 2y is equal to 5. That's negative 1. If I add it to the other side, you get y to the 4th plus 2y is equal to 6.
Mr. George,
Yeah.
isn't it 4y?
Isn't it 4y?
Not 2y?
Oh, I had 4y here and then I mistakenly wrote it that way. Okay, hold on. Something doesn't feel right. Something doesn't feel right here.
That's what I was doing when I did what
Nothing feels right.
Nothing feels right.
Hey, Mr. Madsen. We've got all the folks today.
You need to,
Oh, big dummy. Not me. Me.
What happened?
Okay. So,
Nobody noticed us cool.
no, but it's not cool because I have high expectations and like this class is being filmed and sent out to the world and there are kids at 17. Yes, Prep Campus is going. Why doesn't he know what's going on? I should know.
You have another period, take 2.
I'll just redo it. Okay.
you did.
So the question was, is it possible to have a horizontal tangent line where you intersect the x-axis?
Yes.
Yeah.
If you're intersecting the x-axis, is there anything that you know about the point?
Y is 0.
The y value is equal to 0. So when I get this x equals negative 1, what I should have been doing then is say, okay, so my test is to see, is this point negative 1, 0? Is it actually on the curve? Because if x equals negative 1, that is going to give you a horizontal tangent line. But we need to know, is that also on the curve? And if I plug this in, I get negative 1 squared plus 2 times negative 1 plus 0 to the 4th plus 4 times 0 is equal to 5. That's by plugging into the original curve.
Okay.
Does that actually work?
No.
No.
Right, what you get, you're going to get, what, 1 minus 2 is equal to 5. Negative 1 is not equal to 5. Because this isn't true, negative 1 comma 0,
It's not a horizontal tangent.
no, negative 1, 0 is not on the curve. So your curve won't have a horizontal tangent line when it intersects the x-axis. Yeah?
Then when do you solve, instead of solving for x, when do you solve for y?
So I would focus my attention to the denominator if the question was about a vertical tangent line. Okay, we've got 15 minutes. I want to leave implicit differentiation. This is all the time that we were going to dedicate to implicit differentiation. We're going to stop filming.